Welcome to O-Level Physics Online. In this video, I'll be talking about transformer. What is a transformer? A transformer is a device used to step up or to step down alternating voltage current. A device that is used to step up, meaning to increase, or to step down or to decrease alternating voltage or current. That is what we refer to as a transformer. Why do we need transformer? Why do we need to put transformer in some of our electronic devices? Or why is it that they usually put transformer in virtually all the electronic devices that we make use of at home? All the electronic devices that we have, they have the range of voltage at which they operate. Some of them, the voltage they make use of is 12 volts, some of them 10 volts, some of them 3 volts. Some of them require up to 100 volts. Some materials such as a microwave, such as a refrigerator, a washing machine, and so on, the voltage they consume is very, very high. So as such, if the voltage or the current coming from the electrical alternating current source from PHCN for Nigeria or from the source of electricity generally is very, very low, there's going to be a need for that voltage to be increased for the gadget to have at home to operate. Also, some things such as the charger for charging our phone, as an example, they require very low voltage. So to make the size of the voltage, to reduce the size of the voltage coming to your house to the level that the charger that you have for charging your phone can withstand, we need a transformer to step that voltage down. In summary, we need a transformer to increase our voltage to the required size of voltage that our electronic devices operate on, or to decrease it to the size of the voltage that our electronic devices can operate with, such that in such a way that it's not going to burn that particular device. How does transformer look like, or what is the structure of transformer? This is the normal structure of transformer. The gray color part that I'm having here is referred to as the core of the transformer. We call it laminating core. And inside the transformer, we have two coils there. We have one in the inner part, then we have one at outer part for this type of transformer. Why for some, they are going to be, the coil of wire will be at two sides, one at left, one at right. In summary, the first one, type of transformer, you can have one inside, we are going to have certain type of coil, and outside we have certain type of coil. There's going to be a kind of a barrier between the inner part and the outer part of the coil that we have. And this is just the normal construction of it, how the structure of it usually look like if you have to draw it down. It has the first part that I mentioned, the laminating core, which is a series of lines that I'm having above. And inner part of it, it has a coil which we refer to as what? The primary coil. It's called what? The primary coil. And the other side of it, we have what? The secondary coil. These are the three main components of transformer that we have. The transformer core or the laminating core. The second part we have is what? The primary coil. Then we have what they call the secondary coil. And we have something like a line that has arrow within it. That line is what we call the magnetic flux. It is what we refer to as what? The magnetic flux. And what is the meaning of magnetic flux? Magnetic flux is defined, magnetic flux, which is denoted by phi, is defined as the product of magnetic field and area. The product of what? Magnetic field and area. And that is magnetic field as the unit in Tesla, don't forget that. And the unit, and this other one, which is referred to as what? Area, as the unit in meter square. So simply, we can just say that what? The unit of a magnetic flux is what? Tesla meter square. Tesla meter square. That is what we call the unit of magnetic flux. And two of them is equivalent to what we call Weber. It's what we refer to as what? Weber. Tesla meter square is the same thing as what? Weber. So back to the description of the structure of transformer. Back to the description of structure of transformer. So this is what we have. Primary coil, secondary coil, then we have the laminating coil. And within it, we have one part. That one is not obvious. You not see it when the transformer is operating, and that is what we call the magnetic flux. Then this is the circuit symbol for transformer. This is the circuit symbol for transformer, or the second one. Either you have it like this, or you have the second one to be something of this nature. Now, how does transformer operate? Or what is the principle of operation of transformer? How does transformer work? According to what I have, transformer work based on what we refer to as what? Principle of mutual inductance. It works based on principle of what? Mutual induction or inductance. That is how the transformer operates. And the meaning of mutual inductance is that induced EMF in one part of the transformer. The meaning of mutual inductance is what? Induced voltage from the primary source of the transformer, process whereby that voltage that you have at the primary source is being transferred or being induced at the other side is what we refer to as what? The principle of mutual inductance. Once again, the process whereby the voltage generated at one part of a coil, the process whereby the voltage or current generated at one part of the coil is being transferred to the other part or to the second part of the coil with two coil not joining each other. Meaning the two coil you have here, the one you have at the primary coil is not joined to the second coil. However, any voltage generated at the primary coil is going to be transferred or induced at the other side of the transformer, and that's what they refer to as principle of mutual inductance. And I summarize it here as what I said. According to this principle, if alternating voltage is supplied or applied to the primary coil, as you can see from this side, then it will lead to change in magnetic flux. So what I mean by this is that there's a voltage coming in inward like this, and that voltage here is going to make current to be present at the primary coil, and the voltage or current present at the primary coil here will generate magnetic flux. Now I've explained the meaning of magnetic flux already. Product of what? Magnetic field and area. So that voltage generated in now will generate magnetic flux, and it will link it will link to the what? To the secondary coil of the transformer, and that will be producing voltage at the secondary coil of the transformer. And from this, we revert to this operation as what? Principle of mutual induction. We revert to as what? Principle of mutual inductance. However, the output produced during electromagnetic induction depends on the what? The number of turns of coil that we have at the what? At the secondary coil. The number of turns of coil that we have at the what? At the secondary coil, which will be explained later during the course of my discussion. Discussion. So let's look at the types of transformer that we have. Basically, we have two types of transformer based on the operation, because in terms of what you are stepping up or what you are stepping down, we can classify transformer into either voltage transformer, or we can call it what? Current transformer. But for this case, we are focusing on what type of output are you generating. So based on the outputs being generated, we have two types of transformer. We have something called step-up transformer, then we have something called what? Step-down transformer. And for the first one, which is step-up transformer, a step-up transformer is just a transformer which is used to increase voltage at the output. A step-up transformer is a type of transformer that is used to step up what? Voltage, or that is used to increase the voltage at the output. As you can see from this diagram, to differentiate or to identify a step-up transformer, what you just use is what? Consider or check the number of coils that you have in primary and the secondary. If you look at this, the structure I'm having in this place, the numbers of turns of coil I'm having at the primary coil is very small compared to the number of turns of coil I'm having at the secondary coil. And because the number of turns you have at the secondary coil is more than that of the primary, automatically the voltage generated here will be more than the voltage that you have at the primary coil, based on what you have according to Faraday's law of electromagnetic induction, which states that the induced EMF is directly proportional to the number of coil or number of turns of coil linking the circuit. So if the number of coil you have is more at the secondary, automatically the voltage you have at the secondary is going to be what? Is going to be more. And revert to this type of transformer as what? Step up transformer. Simply, we can just summarize this one, because we can just simply say in this one that number of turns you have in primary coil is less than number of turns that you have in what? In secondary coil for step up transformer. Or in some example, we can simply summarize it as what? The ratio of number of turns of coil in primary to what? Number of turns that you have in what? In secondary is less than 1. It's less than 1. Ratio of number of turns of coil that you have in primary to that of number of turns you have in secondary is less than 1. Or simply, alternatively, you can say number of turns of coil you have in secondary, ratio of it to that of number of turns that you have in what? In primary is greater than 1. I just invert the two. I just did the inversion. Two of them are still the same thing. Then the second one we have is what? Step-down transformer. Now, a step down transformer, from the name, is a type of transformer is a type of transformer that is used to step down or to reduce the voltage that you have at the output. And this is how the structure of it looks like. This is how the structure of it looks like. It has what you call the primary coil as well, and it has secondary coil. But just like the first one that I explained earlier, the number of turns of coil you have in the primary coil this time around is more than the one you have in the what? In the secondary coil. As such, the voltage generator or the induced voltage that you have in the secondary coil will be very, very small compared to that of the primary coil, depending on number of turns of coil that you have there. And another point you can still summarize it again, just like I did for the first one, is that the number of turns of coil that you have in the what? In the secondary is in the primary, or the same thing, number of turns you have in the secondary is less than the one you have in what? In the primary. And vice versa, you can see number of turns you have in primary is greater than number of turns you have for that secondary. And that is what you have regarding this transformer. So turns ratio here, you can easily evaluate it from here. And that is that regarding the issue of what transformer that we have and the types of transformer that we have. In the next video, inshallah, I'll be talking about the calculation part of transformer that we have. So in summary, what we have talked about so far, so far is that we said transformer is a device for stepping up or for stepping down AC voltage. One. The second point that we mentioned there is that we talk about the structure of transformer. We said transformer has what we've called what? A laminating core. We have what we call laminating coil. Then this is called laminating core. Then we have the secondary winding, which is connected to the load. This is called what? Secondary coil or secondary winding. Secondary what? Core or winding. Secondary coil, rather, I'm sorry, or winding. Then we have the primary coil or winding, and that is connected to the source. It's connected to what? To AC source. And another thing that we mentioned is that whenever this transformer works based on what we call principle of what? Mutual inductance. It works based on principle of mutual inductance. And I said we have two types of transformer, which is what? Step up and a step down transformer. I think that's a summary of what we have regarding this video. Thank you for listening. In the next video, I'll be talking about calculation involving transformer.